All right, welcome. It is Wednesday, June 30th, 2021. It is almost Christmas. It is going too fast for me. Unbelievable. What a great day. It's a gorgeous day in Austin. It's a little cloudy. It's been raining in the evenings, kind of in the low 80s. Perfect weather so far. Looking forward to the summer. We have a great guest today. But before we get rolling, Dr. Sibley Butler, a little music perhaps.
Georgia, oh my sweet Georgia, the whole day through, just an old sweet song, keep Georgia on my mind.
All right, Butler, how are you today?
Fine, sir. I'm doing well. We've been having some cool days, in the city, and there are lots going on in the city of Austin, lots going on in the state of Texas. But for the most part, the big thing is people refusing to take their shots. We've talked about that a lot, and the question is, what's the implications for business enterprise? Are we going to be able to open up with a new portion of the COVID come back in and create a whole new strain?
Yeah.
So the news committee is all about that kind of discussion, and the discussion about everybody trying to move, of course, to Austin. And of course, the grid is still on everybody's mind. Like Georgia is on John's mind, the grid is on our mind. And this is the first time I've known in my life where there's so much discussion about the electronic grid.
Yep, I agree. Llewelyn, how are you today, sir?
Fabulous, thank you very much. I had this, before we went on there, I had this discussion with John, and I understand that he is an exemplary man of great wealth, so I'm honored to be in his company. An intellectual too, he told me. So I'm honored again to be in his company. Indeed, I am so honored by this friendship that I may not survive it. I'm very well, by the way, and it's quite hot up here in New England, which it's not supposed to be. John, I'm in Providence, Rhode Island, or just south of Providence, and there we are.
We McDonald, for all those that are listening to us, we call all those provinces East Texas.
Right.
including where you are. So John McDonald, how are you, sir?
Doing well. Adjusting to 15 or 16 months of no travel, Andres. You and I used to travel a lot, and now getting used to being at home every day.
We're all trying to do that.
I can see you pacing the house and climbing over the roof back and forth.
Yeah. My wife and I would go out for dinner on Friday or Saturday night, and instead of going to the restaurant, I would automatically turn onto the interstate to go to the airport. And I don't do that anymore. I just haven't been going to the airport at all.
That's right. Yeah, it's fascinating how we have to adjust for all this long, but hopefully things will get open here. But let me introduce you formally for the record in our audience. So John D Mcdonnell is the Smart Grid Business Development Leader and Senior Fellow of Grid Solutions for GE Renewable Energy. And he's an old friend, a great friend. He's a registered professional engineer, an IEEE Fellow, and a CIGRE Distinguished Member. He's worked at GE a significant time. He happened to be at GE at the time when I was running Austin. We together built the first smart grid at Austin Energy from 2003 to 2010. And that was quite a journey, quite an interesting way of building things when they were not all meant to be together, with bubble gum and duct tape and rubber bands and all kinds of things. Prior to renewable energy, John was the GM of marketing at GE Power. And then before that, he worked at a bunch of other companies. He was a VP of automation and manager substation automation at DMV, Director of MS Business Unit, and Director of Application Engineering at Advanced Control Systems, ACS. I think he's part of Indra now. Manager of Advanced Control Technologies at Cooper Power Systems, and Manager of Power Systems Engineering at Brown Boveri Control Systems, and an Electrical Power Engineer at Bechtel Corporation. John holds a Bachelor of Science and Masters of Science in Electrical Engineering from Purdue University, Indiana. And he has an MBA in Finance from UC Berkeley. Welcome, John McDonald.
Thank you very much.
We're delighted to have you. We are going to cover our typical topics, and to get things rolling, I see that COVID is significantly under control. I know the vaccination is a challenge, but the death toll is basically 2,000 per week being added, and obviously one is one too many, and the devastation is humongous, but it seems to be coming down. Everything is trending down. Hopefully there are no flares from the openings, and obviously everybody's watching with zealousness about that. The economy seems to be, optimistic. The Fed has been doing their job. The GDP is growing. Unemployment is going down. A lot of people say it will be a percent unemployment by the end of the year, the next 6 months. So it seems like hopefully things will come back. There is obviously our big discussion on the divide on digitalization. A lot of businesses and a lot of jobs are kind of not coming back. Waitressing and service jobs and many others are hurting. It's hard to find people to do those kind of jobs anymore. Seems like more and more people are going to the gig economy and finding different ways. But let's, John Butler, how do you see things? Are we in a good place, or where are we at?
I think we're in a place that's always in the becoming now. I think there's nothing necessarily related to what I would call equilibrium, taking a page out of economics. I think for the first time, we're already sort of in the becoming, but it's sort of sped up a lot. And if we look at the indications, so we look at the job market, how jobs are being created, what we don't know, we do not know the number of people that's moving from the gig economy to, quote, regular jobs with standard kinds of things associated with them. We also really do not know if the gig economy will completely come back. If you look what's happening in Austin, it's difficult for people to come back to work in restaurants and those kinds of things that we've talked about so much on the program. On the other side of the ledger, the economy appears to be extremely well in the aggregate. That is, the housing market is booming, not only here in Austin, Texas, but it's booming around the globe. And the big question is what will happen when the United States government take away the subsidies for rental, and everybody who cannot pay their rent and cannot pay their house note will be called to the carpet to pay up. That might have a big impact. The other thing is the mask. I think that in Texas here, when I go to stores, people still have a mask on. I was in HEB and the masks are still there. I see again a sort of a tension between the ability to say that I'm not going to wear a mask and to wear a mask, and the unknown now is who has the vaccine and who does not have the vaccine. So in all my invitations now, the first thing is we've had our vaccine for the last month and a half. So that's becoming a standard kind of thing. But I think if you look at the country overall and you look at how it's opening up, but as Llewelyn would always tell us, it's going to be different. It's going to be different in a lot of ways. People would do lots of different kinds of things, but it will be different. So we're opening up now, but if you look at what's happening, if people do not take their vaccines, we might be dealing with two Americans, and people might create different kinds of relationships. The big one is what will companies require? So when I go back to the University of Texas, my students are not required to take the vaccine. And I think a lot of companies are struggling with that now. So again, it is non-equilibrium. It is certainly in the becoming. And it's a good time to be alive to watch all of these trends.
Well, I don't have the temerity to totally disagree with Dr. Butler. I have to remain somewhat in his good graces. However, I think that there is a false optimism about the economy because something huge is happening, and that is the drought in the West. It is enormous. I've been doing a lot of reporting on it. I did a special program for the U.S. Energy Association last Friday. I had the head of the California ISO on, somebody from the Energy Information Administration, and two residents of California. And the whole situation in the West for water and for heat is catastrophic. And it isn't going to get better suddenly. And no law can be passed in Washington which will ameliorate the suffering and the changes which it will occasion. For example, the cost of meat and vegetables traditionally grown largely in California, exported to the rest of the country will go up. We'll be importing more necessary vegetables, etc. But we also will see unemployment and companies fail. We also will see a heating of the markets for housing, as John mentioned, in the East, as more people decide their futures are not as they had thought in the West. You really got to love sunshine to want to have the temperature go to 120 degrees. It is lethal if you stay outside too long. It is lethal if the power supply stops, and the power supply is stretched. The Western interconnection, as it's called, is really at its peak, and it really cannot accommodate any more or any sudden and unexpected change in supply. So this is a very critical and dangerous moment. Suddenly, and I think belatedly, the administration's woken up to this reality and is trying to do something about wildfires in the West, which accompany this kind of heat, and dryness. But even though the heat will abate, the dryness will not abate. There's no guarantee that normal rainfall will resume. We've had reduced rainfall in the West since 2000. This is a long-term drought. It may change the places people want to live, the kinds of industries you can conduct in the places that are affected. It is seminal, and it's disorganizing, and it's worrisome.
Another pandemic. John McDonnell, you're at GE, you're a global company. We talked earlier that you and I are not traveling as much as we used to, but give us a step for COVID. What has changed at GE? Any lessons learned? And how do you see the economy, especially on the energy sector? Are things coming back? What's your take?
I wish we had a really good crystal ball, because two things. I think one is what will be the new normal? We know it'll be different than what it was before, but we have no idea what that's going to be. And the second part of that is the timing of it. For instance, we're planning a CIGRE, hopefully in-person event, Grid of the Future conference, middle October in Providence, Rhode Island, where Llewelyn is, hosted by National Grid. And we thought things would be the new normal. Things would be opened up. We'd have a 100% in-person event, with about 250, 300 people. And I'm collecting papers for that. Okay. And when I put out the last call for papers yesterday, a lot of people are saying, "Hey, John, I want to do a paper, but I'm not sure I'll be able to travel to present the paper." So there's still a lot of uncertainty. People want to travel, but the question is, will their companies end that travel ban? And when will that happen? So that's one thing. The second thing is, what's really been interesting to me with our industry is the impact of COVID on our industry. I can tell you, Andres, that a lot of utilities have said, "Hey, we're increasing our." First of all, we've shown ourselves we can do more things virtually than we thought we could. Okay, and we're increasing our budgets for remote monitoring and diagnostics of transformers, high voltage circuit breakers. We can reduce the number of times we send people out in trucks. We've shown ourselves we can do more virtually, so we want to buy more M&D equipment and do more with asset performance management, than what we were doing before. So I've seen from an industry point of view, that's a positive impact for a supplier, that's great. But the third thing is something actually a key industry senior executive said in Texas, okay? And he was sitting in his office building in a large city in Texas, downtown, on a weekday and looking out at other high-rise buildings that used to have lights on, used to have people working. And he said, we as a utility and all the other utilities spent a lot of money on the resiliency of the grid in the downtown area because there was so much at stake. People were working downtown, people wanted reliability. He says, now this workplace has shifted to the suburbs. It's not downtown anymore. And the new normal will probably be, a lot of it will stay in the suburbs. He said, but the problem for us is people expect the same resiliency and the same reliability that we invested in downtown. They expect it now at home, and that wasn't a priority for us at the time. The priority was the downtown area. So that's an interesting perspective, I think, on the grid, with the new normal. We're going to have many, many more people working from home, and their expectations are going to be what they had when they were in a downtown office building.
Right. So clearly, John, I think everybody knows what GE does, and everybody knows Edison, and you being in the renewable group and doing smart grid stuff. I think everybody knows what you all do for a living. But let me ask you a couple questions, and maybe these tease up some of the things that you're seeing in terms of demand and trends. We have all kinds of things going on. I'm going to read some of our highlights. Oregon leaps past California and Washington as legislators pass bill to decarbonize their power grid by 2040. So one question would be, and park that question for a moment, is it possible? Can we go 100% decarbonized by 2040? Bechtel announces partnership. We're constructing new data centers that are more efficient. They're claiming 70% less energy efficiency and not use of water for cooling. Wow, that's phenomenal. I would love to see all that technology. California braces for energy resources shortfalls amid extreme heat and drought. This is back to Llewelyn's point. Grid-wise members asking for $50 billion for smart grid upgrades. I'm sure you're aware of that. You probably participate in some of those meetings. C-Power adds 364 newcomers. Hits 4.3 gigawatts of DER. DER, the new front. Curious why you're thinking about that. And then last but not least, Biden administration wanting to create grid authority. I thought when I read that, I thought, oh, John McDonald should be in the job. That should be his job. So John, what do you think? Can we get to zero carbon and by 2040? Is DER the new future? What's going on?
Well, the one thing that I think will help us, Andres, is I see a lot more emphasis on this than I did before. At GE we have a corporate sustainability program with executives in charge, a lot of priority and focus. And when you put, like anything else, when you put researchers and you put some money behind it, it's amazing what progress you can make. So I really think that because we have renewed focus, much more focus, much broader focus by more companies with transparency, with targets, with progress, with status reports, I see more progress being made than we did before. The one thing, though, I think that that we need, as if you're an operator in a control center, you can't regulate the grid with a windmill or a set of PV panels. And also you need some amount of inertia, right?
That's right.
When there's a problem on the grid. So I think, we have new technologies that we haven't seen yet that we need to truly get to that point, Andres. I think we need better chemists. We need more cost-effective energy storage. Okay. Right. that is more cost effective across the business cases for all the applications, whether it's instantaneous needs like frequency support or longer time like peak load deferral.
Mhm.
We need, I think, new innovative technologies like we at GE, we announced a couple of years ago an electronic gas hybrid turbine, which is an optimized package of 10 megawatts of lithium ion batteries with a 50 megawatt fast starting, fast responding natural gas fired turbine generator.
Mhm.
So you have both the instantaneous response and a longer term, and it's optimized to work together. So I think
Right.
we need more innovative solutions. I think we can get there, but you still have the intermittency of the renewables. We all want our lights to be on all the time, even when the sun's not shining and when the wind's not blowing. What's going to do that? We need cost-effective solutions in that way. But there's so much emphasis on that today. I think back to the space program in the 60s when Kennedy, had that mission and there was everyone rallied around that and with research and money and it got done, and I think we have a good shot. If it was I don't know, not too long ago, I'd question it because we just didn't seem to have the focus that we have today. I see much more focus today.
John, can I ask a question? I've been around this for quite a while. I've been writing about the utility industry and its suppliers, particularly at one time GE, since 1970. And I've seen various brainwaves go across the industry when everybody was building a nuclear power plant, no matter what. Some of it was crazy, like Delmarva wanted to build 12 gas-cooled reactors when they didn't really exist, and it was a tiny utility. And yet everybody now talks at the age of renewables about saving the nuclear option. Right today, I just got a press release. Con Ed is asking people to save power, but nonetheless, Indian Point serving New York closed down. California is short of power and it's going to close its remaining reactor. This is insane to my mind. And I wonder to what extent then we went from the absolute love of nuclear to the love of coal. Then we had a little problem with acid rain, so we said we'll put up tall stacks and that'll solve it. It sent all the pollution to another country usually. And if you were the receiving country, you weren't too happy. And then we suddenly discovered aeroderivative turbines, which GE was a leader in. And I went to, I think, one of your plants in Ohio to see them being made at one time. And this was the brave new world of the gas turbine, not the heavy frame, but the aeroderivative, light, portable, efficient beyond belief. And suddenly, of course, gas is out, and now the passion is for windmills, which have their own downside, and for solar, which probably has its own downside, especially as we don't make them here. I mean, are we off on another wild brainwave chase? Shouldn't we settle and make some electricity in time-honored ways like nuclear? Indeed, GE, once a leader in nuclear with the boiling water reactor, seems hardly to have a foot in it. This is not a very solid future that we're building, electric supply. At a time of shortage, we are still closing nuclear power plants because the day-to-day economics don't add up, but the year-to-year and generation-to-generation economics are fabulous.
Right. I agree with you, Llewelyn. In fact, think about 1974, I graduated from Purdue with a master's degree, and my first job was with Bechtel Corporation in San Francisco. We had 12,000 people at the home office, many of them doing nuclear power plant design. That was the heyday of nuclear until 3 Mile Island, a few years later.
I think the man leading it was Bert Wolf.
Yeah, I myself was in a mining and metals division because as a young person, I didn't want to get on a nuclear project and be on the same project for 10 years. I wanted, but it was, I think there's a couple things. One would be, when Fukushima happened in Japan, And people said, well, we're going to replace the nuclear reactors with wind and solar. I said, wait a minute, you can't replace non-variable generation with variable generation. Just what I mentioned, Andres, you can't regulate the grid with variable generation. It just doesn't, ask an operator in a control center. So you can't, like in Japan with Fukushima, you can't replace a bunch of nuclear plants with variable generation. It doesn't work from a grid point of view. And I don't think a lot of people realize that, truthfully, the general public. Secondly, I think we've shot ourselves in the feet in the US with respect to how cumbersome it is with licensing and the multi-step licensing process and the risk, the financial risk with nuclear. If we could have early on, and I wasn't involved in this, but if we could have early on streamlined the licensing process, standardized on maybe a few reactor designs instead of having a whole bunch, have a few, put them through the test, have standard designs, have a one-step licensing process, minimize the risk, then I think we would see more nuclear and more acceptance of nuclear. But it's a struggle. And, living in Georgia and watching Plant Vogtle with Southern Company and the delays and the extra costs, I mean, it's tough for the general public to support because instead of hearing a lot of positive things, you hear a lot of negative things, extended timeframes and increased costs. So I'm all for nuclear. I just think we really needed to streamline it to minimize the risks.
Butler.
Yeah, John, in an interesting way, we're still in a public-private partnership, and the grid is still public and private. And you mentioned how difficult it is, and we've talked about this on the program. And I, for the last 9 years with Richard Schrittle and Andrea's been looking at a lot of the grid stuff. And basically, if you look at a thing like SCADA, right, which is designed to control the grid, and all of a sudden we still have people pulling levers rather than making it very, very smart, as Andreas would do. We should do that, in the whole country. So my question is, this technology moves at glacier speed, right? You're at a great private company that needs this technology. Do you see any pathway for private firms to get involved in really redoing the grid? I would love to be a fly on the wall, if you will, at your conference, because we have so many people with grid strategists. We've got the US military, we got the Air Force, we got everybody has a grid strategy. So my question is this: given that private enterprise now with electric vehicles and et cetera, and given the demand in the future, will companies like GE step forward and say, look, we need a new technology on the grid. We go from the grid age, we need to stop SCADA and make it and update it, put in a new technology so that we can have the entire grid very, very smart, and it can get hacked, of course. Mm-hmm. But will private enterprise get more involved with that, or would they just sit back and look at a grid that's running on 1922 technology?
That's a really good question, John. I would say first, with respect to SCADA, I've been involved with SCADA for 47 years, and I wrote a book on SCADA that was published in 2015 called Power Systems, SCADA, and Smart Grid. So that's something near and dear to my heart. But I would say that, and Andres, at Austin Energy with being a CIO, and I think we would say that SCADA has been an area that's pretty well kept up with technology in general. It's become more cost effective. When I started in SCADA, it was very proprietary. Remember, especially EMS systems for generation transmission were custom. They were always late. They were always well over budget. But then we all got smart and we said we need to standardize SCADA, and we did. And it became much more standard. So I think, here's what I think about the grid, though. I was on the board of the GridWise Alliance from 2007 to 2010, then again from 2016 until the end of last year when I was term limited, but I'm still active with GridWise. You may remember we did some regional workshops on what the future of the grid should be. And then we took those regional, the regional input, you know, and consolidated that into a national input and had a national future of the grid workshop in Washington, DC. And out of that came really the blueprint for what we all felt the future grid should be. Now, the question is, how do you make that happen? You know, you mentioned funding. And if you think back, I think a good analogy is think back to the 50s with Eisenhower and his plan for a national highway system. You know, if you read the steps that Eisenhower took, he put some basic national rules together, you know, like numbering, whether it's north or south or east or west. And, you know, the number system we have today that tells us, the number tells us an idea of the orientation of the highway thing. That was done early on a national basis. But then the federal government said, you know, the highways in each state should be done by the state, right? But per some national guidelines, and then empower the states to do it with some funding, okay? And out of that grew our national highway system. We feel that an analogy for the grid is very appropriate. Take the blueprint that we put together a couple of years ago and empower the Department of Energy to be the Eisenhower with the blueprint and with the funding, you know, but the funding has to be there, and then empower the states to implement that blueprint with some national guidelines, but per what a holistic view of the grid would be for the US, not a siloed view, right? Like this co-op, this muni, this IOU, this state, this region, but a holistic view. This is what we came up with the Gridwise Alliance, a holistic view of the grid. But we felt, you know, you need a national organization empowered to do it like Eisenhower did with the highway system. And I think the DOE is a good choice. And then funding to empower the states to do the individual implementation of the national blueprint.
That's an interesting point, John. I'm gonna come back to that point in a different way. So you're familiar with the snowmageddon that we got here in February in Texas,
right?
And I'm sure you have an opinion about it. And I know also that GE play role in the comeback of Puerto Rico and after the Maria hurricane that destroyed their transmission lines and everything. And they actually rebuilt their grid into, I believe, 4 or 5 microgrids. In Texas, they still haven't decided what they're going to do grid-wise, and I don't think much will be done. But clearly, then we used to have 11 balancing authorities in Texas before we went to ERCOT into 1, and there's some thought that maybe we should go back to perhaps no 11 but 8 balancing authorities and really fortify the grid in a different way, focus on region and who's doing manufacturing and X, Y, and Z, what kind of needs they have. What are your thoughts on the fact that DER, distributed energy resources, solar panels, energy storage, electric vehicles at the edge of the grid are happening? The genie's out of the bottle. Tesla has won the argument. They may not end up being the long-term winner on the electric vehicle car companies segment, but they definitely, it's happening. All the EVs are coming from all the companies. There may be a challenge of 200 million registered electric vehicles, and where is the generation for that going to come, because we don't have enough. But don't you think that the shifting of building a big comprehensive grid is being actually challenged by a decentralized small microgrid architecture, and that should be the way? What's your thoughts?
I think it's a hybrid, Andres. I think it's a hybrid of both, because I think the national grid, like what we talked about, I think is needed. There's so many benefits of that. We say that if you manage renewable energy on more with spatial diversity, there's economics with that. If I'm managing renewable energy in a very small area, the sun may not be shining, right? But if I widen that area and I have spatial diversity, so the sun may be shining in one part, but not shining in another part. And if I can manage over a wider area, I have much more economics. I can use my resources to a greater extent.
Right.
So I think a national approach is a good one. But then within that national approach, like many utilities are doing today, for local resiliency, is strategic microgrids. That can be islanded if they need to. They have their own generation. Like ComEd is putting in, I think, 5 in the Chicago area. Like the Bronzeville microgrid is a good example. What's interesting is it wasn't too long ago when we heard about microgrids, they were very niche. University campuses, military bases, and rural villages. And at GE, our first microgrid project was a rural village in British Columbia, not near any utility, but they had hydrogen fuel cells, they had PV panels, and they had low head hydro generation. Now it's different. Microgrids now have a renewed emphasis with resiliency. Okay, so I think the future grid is really a hybrid. I think we need strategically located microgrids, but I think we need a national blueprint because of the economics and benefits from the spatial diversity of doing something on a wider geographic area. You just don't get the optimization when you localize everything.
What's your take on and I wrote this in chapter 11 and chapter 7 in my book in 2011, that every house and every building should become a power plant. What's your thought of that?
I think that's a possibility, Andres. And I think, if you look at, just take the new electric Ford F-150 truck. Andres, when those batteries are charged, that one truck can power a home for many days.
That's right.
I mean, there's so much energy in that the batteries of that truck. So, and my wife and I just ordered our first Tesla just last week.
Congratulations.
Okay? Yeah, we're in the queue now. ETA is about September but I see more and more people getting EVs, right?
Yep.
But I think like much of what we do, the technology that you and I work on is the easy part. To me, the policy part of it is the complicating part. And I think for V2G, vehicle to grid, for using homes like you wrote about as a part, I think we need some policy issues with that. For instance, if somebody else is using the energy in the batteries of my truck, and I lessen the life of my battery because increased charge discharge cycles, who compensates me for that?
Right.
Somebody's benefiting, but I need to be compensated. My batteries are being used.
Yeah.
So, I think the policymakers, we need to equitable policy to handle something like that. But technology wise, there's no question. I think that's the future, but it has to be equitable, and it has to be a win-win situation for everybody. Everybody has to be happy.
Yeah. Let me pause for a moment, John, and let me share my screen real quick to do my commercial that I have to do for our conference in person, August 31st to September 2nd. Looking forward to have you in the Embassy Suites in San Marcos, just south of Austin. We're expecting 100 speakers, 400 companies. There will be 2 awards, 1 showcase, over 1,000 attendees, 20 keynotes, 14 panels. These were the speakers last year. Hope to see many of them come back. And I want to say thank you to Texas State University for sponsoring the roundtable today. John or Llewelyn, any follow-ups?
Yeah, I do have a question, John. When we talk about going back to the future, my father did the electrification of rural. He was an agriculture agent in southern Louisiana. And when I was a kid, they talked a lot about, and I read his papers and his theses and stuff. They talked a lot about the fact that the family farm was completely self-sufficient when it came to electricity. It was done through windmills. Then all of a sudden, they talked about hooking up with the larger grid in the larger cities. So how has the basic technology changed? I mean, not the technology, but the thinking changed. When we would say that, every home should be responsible for its own electricity, that sort of takes the burden off of my electric company and kind of puts it on me. What we say is that microgrids are very, very interesting. Who's going to run the microgrids? What's the relationship between microgrids and the political process? But more importantly than that, of all of the companies that's moving, for example, to Austin, Texas, or to Texas, what are the policy kinds of directives? I mean, everybody coming here will need electricity. We have not talked at all about the hundreds and thousands of startups that's moving here and the need and what that would do to the grid. So are you suggesting then that everybody would do a microgrid? That Tesla needs to buy him some Ford F-150s? What's the overall policy when I wake up in the morning and say, wow, look at my neighbor's house is booming. Look at my house. I need to get an F-150. What does all of that mean in terms of the policy and responsibility of the state, responsibility of the community, responsibility of ERCOT? What does it all mean to me as a consumer?
The thing, John, with consumers is consumers would be moving, and companies, right, to Austin or to Texas without really thinking about the electricity. They're just assuming that they're going to have what they need and it's going to be reliable, and they'll pay for it, but it'll be reasonable. So the question is, somebody has to plan for that, right? Somebody has to put the infrastructure in place, the policies in place, and then if a bunch of people decide to buy EVs, they're going to expect that they are going to hire an electrician to run a new 50 amp circuit to their garage, and they're going to expect that when they plug in the fast charger, that they're going to have the electricity they need, right? Mm-hmm. The distribution transformer will be able to handle it, and the distribution grid will be able to handle it. So you're right. The utilities and the policymakers really have to forecast that and plan for it. But you brought up a good point about self-sufficiency. What's interesting to me is in countries like, there was an article written in the state of Queensland, Australia, where the policymakers changed policy almost overnight to make it very attractive for the homeowners to put PV panels on their roof. We did an IEEE TV video on smart grid, and we went up on the roof of a guy's home in Southern California. He had just put PV panels on his roof, and he said, the business case for me pencils out very, very well. When I consume electricity, I pay 10 cents a kilowatt hour. But when I sell it back, the CPUC, California Public Utility Commission, requires the utility to pay 40 cents a kilowatt hour. So 40 versus 10. That's why so many homeowners went and put the payback period was shorter than what they thought. Well, this happened in Australia and Queensland. And the fear of the utilities, the two utilities at the time, were that, and this happened, homeowners said, hey, I've got my own generation. Do I really need the utility? And the fear was that many consumers would say, I don't need the utility, and would leave the utility. So then the utility with revenues would drop. And what they would have to do is raise their rates to accommodate that. And as they raise rates, more consumers would leave because the rates are now higher. And that's what we call the death spiral. Okay, mm-hmm. Eventually the utility would be out of business. So the lesson learned for utilities with the death spiral was you can't just be a single service provider. You can't just provide consumers electricity. You have to think of a whole bunch of services you can provide homeowners, electricity just being a small part of it. Because if that's all you provide, the risk is you may lose customers, when they put PV panels.
Great answer, Don. Let me ask you this.
Yeah.
So that means Google, who has all the customers in the world already and service my home. That means that AT&T, that has all the customers in the world. That means that Walmart. That means that Amazon.
Right.
So are they going to buy electricity wholesale and guarantee it to me retail, because they have all the data, they have all the consumers. So where does that lead? It seems like to me that the private firms will step up and say, wait a minute, I know everything about Andres. I know when he turns his work on, I know when he orders. And by the way, I have millions of homes with this data. So to service, why should I depend upon the grid? Let Amazon or Google buy it wholesale and sell it to me retail.
Well, let me comment on that, because Google, as Andres knows, Google put together the power meter, and they tried to get into the business. And what they found was, John, it's not that easy. This business is not an easy one to be successful in, and Google eventually dropped out. If you remember, Microsoft tried to get into the home energy management business and eventually dropped out. So now, but Amazon Web Services is partnered with Intel, and they've formed what they call their equivalent of Best Buy's Geek Squad. And they eventually started in 14 states in the US with the idea of, let's promote in-home enabling technology that's Intel based, right? Intel supplies the products. AWS, their equivalent of the Geek Squad, they will go into your home, install stuff, configure it, support it, right, over the long term. So I think, Amazon and partnered with Intel saw that opportunity, and they're trying to take advantage of that. But I think, first of all, you have to understand the business, and you have to understand how to be successful. You just can't jump into it like anything else and assume you know the nuances of it.
I agree with the strategy.
Yeah.
Thank you.
Llewelyn?
I'm wondering about two things. One of which is, do you see any new generating technology at the edge? Anything that may change this? The other one is, when we look to future growth in demand, we tend to look to electric transportation, but we may have electric construction. We've started 3D printing houses. If we go that way, electricity demands go way out of sight. If every new construction, or half or a third or a fifth of the new construction in this country is 3D printed, the demand for electricity is going to dwarf the demand for electricity for the F-150s.
Agree. I wrote an article for Power Electronics magazine about 8 years ago, and it talked about new applications of, this is low voltage power electronics at the edge of the grid. So we do have new grid edge controllers, and what caused their need was when you have a high penetration of rooftop solar panels, the intermittency of the sun creates tremendous volatility in voltage and reactive power on the low voltage network. So I studied a distribution feeder. It was in San Diego Gas and Electric. Over 35% of the homes on one feeder all had rooftop solar panels, and they installed them fairly quickly because of the change in policy in California. The tap changer in that substation was operating about 5 times a day. All of a sudden, all these homeowners install rooftop solar panels. And these are beautiful homes along the Pacific Ocean with a marine layer of fog from the Pacific Ocean. As that fog burned off in the morning, all of a sudden you have all these homes on the same feeder begin to generate. And I have voltage waveforms in my article. You should see the voltage, like a rocket. It just shot up in the air, right? And then oscillated. Well, the volatility was so great, this tap changer now is operating over 120 times per day. It's a mechanical controller, so it needs to be replaced in 2 years instead of 35 years. And so a couple things. One was, I said, mechanical controllers will not work with a future grid. As the penetration of renewables grows, we need power electronic based controllers. They'll wear out too quickly. And the second thing is, we need to mitigate that volatility on the low voltage network. We don't want that volatility going up into 13.8 kV and going up into the grid. That's going to create havoc. So we have they're continuous set point controllers, low voltage power electronics that we install at the very edge of the grid. And they're almost throwaway. They're not real expensive. And we do system studies, load flow studies to determine how many we need and where they should be put. So we've truly distributed intelligence down to the edge of the grid. And it's really needed in places where you have a high penetration of rooftop solar PV. Yeah.
So is it fair to say, John, that for the most part, energy storage aside, we do have today sort of all the technologies and all the key elements to deliver this two-way power flow grid, maybe not as cheaply as the one that we have since 1920s, but, it would be super advanced. We can do all kinds of hybrid, things, centralized geospatial management, microgrid, resiliency. I mean, we have all the technology today, right?
I would say, Andres, it'd be nicer to have more cost-effective energy storage, one. Two would be more solutions, more cost-effective solutions to deal with the different timeframes of intermittency. The energy storage can handle instantaneous many times, but longer term, like really fast starting, fast responding natural gas fired turbine generators that are cost effective. Third thing would be we really need to rethink the controllers we have on the grid. And I'll tell you, when I go to universities, I try to convince the power electronic researchers in electrical engineering to work with the power system researchers in electrical engineering. In IEEE, we have the Power and Energy Society, and we have the Power Electronics Society.
Right.
And we don't do that much. I mean, we try to work together, but we really don't.
Right.
We can't be siloed. I wrote this article 8 years ago in Power Electronics Magazine to try to encourage, we really need power electronic expertise in power systems, because these mechanical controllers we've been using for decades, as the penetration of renewables grows, their lifetime will be much shorter. So I would say those are some of the things. But other than that, I would say the biggest challenge we have, and I'd like to hear your reaction to this, Andres, being at your years at Austin Energy. I tell students at the university, I say, you think your studies are difficult. I said, the technology and what you're learning is the easy part when you start working full time. I said, the hardest part when you start working full time is you develop the technology. Now you have to convince a customer to do what they were used to doing for the last 10 years in the future, different with your new technology. To me, the cultural part of what we do to get people to change, I took 2 electives I took at Purdue University as an undergraduate EE student were psychology courses, okay?
Yeah.
And I tell EE students, I said, you need to take psychology. You have to understand people and how to engage with people, because the technology part of what we do as we look to the future is the easy part. I can put logic on the distribution part of the grid, fault detection, isolation, restoration. Within a minute or two, I can detect the fault, locate the fault, isolate the fault, restore service upstream and downstream. But I need the customer to be confident with the logic and let me close the loop.
Right. Well, I remember, the reason that resonates and makes me laugh is when we had it snow in Armageddon, a lot of people call me up, and these guys, I thought our grid was smart. And I'm like, it is. All kinds of infrastructure, distribution automation, ADMS. If we have smart, it's all interconnected. So why are we doing the rolling blackouts at the feeder level? And I said, well, because that's the policy. Never wanted to change. Don't trust the computers.
You're absolutely right. And Pittlin at MIT has written a great book called Social Physics that tries to address exactly what you would say. And Andreas had me working on, we don't call them customers anymore. They are something. They're digitized things within the networks that we work in, because they come back at us just like machines. But that's very, very interesting. And I also think this is the most important problem moving forward in the 21st century.
Yeah.
Yeah.
Electricity.
Yeah. One of the things, you know, and I know we're coming through the hour here, but you know, go to you in a moment, Llewelyn. I fantasize about this, John, and you and I talked about this tap changer thing many times, to the point where at some point the tap changers will need to be switched every 2 hours a day, you know, because they were. But if you take all these electric vehicles and they all had 100 kilowatt hour battery, there's 100 million registered vehicles. That is 10 gigawatts of power. I mean, 10,000 gigawatts of power, and 10,000 gigawatts of power. I mean, like, where are they going to be charged? How is that going to work? And I mean, the dynamics are there for this distributed grid to happen. I think that it'll be interesting to see how it evolves. And you're absolutely right. The policies, what gets in the way, the rules, and the unfortunate fact that the Department of Energy is really not in charge of electricity and power. It's more of the things. And, you know, Erica doesn't even park. So, I mean, you know, it's crazy. Llewelyn, you had a point.
And well, my last question is more philosophical. We have, what is it, 2,000 utilities in the country. I mean, 60 huge ones.
3,000.
3,000. Yeah.
Many, many small ones, 3,000. But they're not in competition. So we're not getting the benefits of the creativity that comes with competition. How can we incentivize them to compete and therefore to invent and therefore to change things?
Well, so real quick, some states have competition at the retail level and then in the generation level. The grid itself, the wires business, cannot be competitive because you cannot have multiple wires. So, but that's only in 16 states. So go ahead, John.
No, that's what you said. There's some fundamental, right, foundational things that prevent it from happening. But I'm all for that. A competitive environment is a healthy environment, you know.
I think we hived off too much of the electric research to, say, the Electric Power Research Institute. We don't have individual companies as we once did with their own research departments coming. The big investor-owned utilities did a lot of research and came up with a lot of good stuff. It's not that the EPRI doesn't do a lot of good work. It's just a totally different dynamic. And it's not in competition. It's in service, which is rather different.
Yeah, and also electrical engineering is taking a high seat to mechanical engineering at universities. That is, if you look, we can always use actuators, right? But if you look at how universities are going and what happened, Llewelyn, in 1980s, they switched all of the research from private firms to something they call major research universities. So one thing about the major universities, which I'm part of, is that it's difficult for them to understand the relationship between industry and what's going on in industry. Professors,
that's another subject of the role of the universities and the dispersal of the research funds to, often for political reasons, of course, not in Texas, but everywhere else.
Well, in Texas, we can't understand, but
and you don't have sufficient concentration of wealth to execute anything.
Yes, but the big thing is, how do we get the university to understand the priority of research that can help industry? That's what John was talking about earlier.
Yeah.
How do we get rid of the silos? We need to get rid of the silos, you know, and then for the commercialization, you know, you need finance and management in every discipline in the university, but that's a whole nother problem.
Yeah. Now, in closing, John McDonnell, you've been in this industry for a long time. We've known each other for a long time. Tell me true or false. It has never been any more exciting time to be in this business, and the amount of innovation coming through you every day is unmanageable.
Clay, Andres, a good support of that is, even my manager asked me this for my annual review. John, he said, do you have any plans to retire? You know, I'll be 70 in December, right? This is my 50th year at IEEE, right? And I said, I haven't even thought about it, just because of what you said, Andres. It's so exciting. You know, we thought we had changes 40 years ago. They were minuscule compared to the change. We have revolutionary changes today, and they're happening like the 100-year flood happens twice in 10 years, you know? I mean,
Right.
we have so many things happening that challenge us. I'm having more, like you, I'm having more fun now than I've ever had. And I'll be 70 in December, and I'm having fun. I have no thoughts of, you know what's exciting to me, Andres, is the journey to digital transformation. It's
Yep.
you know, we went from reactive, we're now learning about predictive, but we're only halfway in the journey. And that's what's exciting to me, is with more artificial intelligence, more machine learning, more of the use of the digital twin, we can get all the way to autonomous. And to me, if I was a young person, I would get a master's degree in big data, you know, in data science, and I get a master's degree in power systems, and I'd have the golden combination of what's needed in the future. We're hiring data scientists, but we're teaching them about power systems. You can't take a power person and teach them data science.
You know, data science is just old statistics. So you go to psych, you go to social, you go to economics. It's been there for years. We got to learn to apply it. You know, but that was one of my things in graduate school was that organization science. So the students now in social and statistics are just booming as data scientists.
Right.
So, we've got to get the data scientists and it's already in disciplines, but you got to change the variables, what you have to do. Yeah.
Well, come to the Digital 360 Summit. Dr. Arshad Manzoor, CEO and President of EPRI, is keynoting the Smart Energy and Utilities session, and it's going to be a beauty. John McDonald, thank you for being with us today. Much appreciated.
Thank you, John.
Namaste. And John Butler, take us away with some music.
I'm leaving on that midnight train to Georgia. Ooh, y'all. Well, I'm going back to find a good place in time. Yes, I will. Oh, and I'll be with you. I know you will. On that midnight train to Georgia.
Excellent.
Fantastic.
Bravo.
Thank you very much. Thank you very much, gentlemen.
Great to be with you and great to meet you.